All right, time for, what is this, number 3? Yeah, we're chugging along this evening. 3 in an hour. Let's see what's next. So this one's going to be, I believe it is a malware analysis 1. So we're going to dive in and have a little bit of fun with that. All right. Let's see. Suddenly we got an elf or received something. Elf McBlue, the years of experience without Miss There's Miss Skitty again. So last time we saw Mick Skitty, we got one of those other clues. Let's see. Today's room will have you taking the place of Elf McBlue, a highly talented member of the Best Festival Squad. You've been tasked with investigating a highly suspicious executable that is being shared within the company. In today's room, we will be covering the following: principles of malware analysis, an introduction to sandboxes, static versus dynamic analysis, and some common tools of the trade. These are very common. Start your target machine. Boom, let's do it. Start our machine. The machine will open in a split view within about 2 minutes. We do have Elf McBlue's credentials here. So this is the file, and we don't want to execute it yet because it probably wants us to have procmon and red shots running before we do. I'm sure it'll tell us what those tools are so that I can tell you. But they're tools to watch for stuff that changes on the system whenever you execute. All right, so what is malware analysis? Malware analysis is a lot of fun. I wish I had more time to dive into this previously. I did do it for a while, but I wouldn't say I ever became like a master at it. I wish I didn't have enough time, but it is very fun. So if you like exploit dev, you like getting into assembly and all of that, it's a really, really fun skill set. But it does take a ton of time to develop. If you're not programming yet and you're interested in it, you better get to programming. You're going to need it because if you're analyzing code, you need to be able to understand code and probably be able to write it yourself as well. I mean, in a lot of cases, you'll see where malware analysts have written things such as ransomware decryptors and things like that. So coding comes in handy, patching code, all this kind of stuff. It goes in there together. So really good skill. It's good to know how to program regardless because you're going to be doing automation, tool building, and all of that. So that's a good time. All right, so I want to skip all this boring stuff. Let's see what it says. What is the hash of hophelper.exe? So typically there are tools, and I guess they don't have them added on here. SHA-256. Well, maybe I need to figure out where their hashing tools are. Usually, like in my lab, I just right click and it's there, but no worries. Let's see. For us to stage file property within the table of interest, is that what we're doing? Oh no, we were using PE Studio, I bet. Here we go. Copy value, that's what we want. All right. Let's get back to it. So we will need to... Nope. Okay, I thought we were going to have to copy and paste out of here. So with the strings of hopper.helper, a flag is in there. So strings is a fun one. So if you don't know, strings is basically there's 2 different types of strings that are in a file, and it's basically like the human readable representation of stuff. So it's usually like a set of, I can't remember what the default is, it's like 6 or 7 human readable characters in a row. So ASCII is one of them, and Unicode, that's what it is. Unicode and ASCII. So what we can do is we know there's a flag, so it could probably sort by length, if that's possible. It's not possible, so it's just iterative. So we're just looking for something to stand out. So as you can see, it is human readable, right? We're able to read most of this. And these are human readable characters. It just doesn't mean anything to us, by the way. But these do. Argument out of the domain, that's pretty human readable. But we're looking for a classic CTF flag at this point. And it says it should start with THM. So with that, we have it listed in alphabetical order. So we should just have to go to T's. Here we go. So it should be after these TH M strings found. So this is the value. And if you haven't done any capture the flags, this is kind of the formatting where you have like maybe the name of the CTF with a set of curly braces and then your flag in the middle. That's pretty common. All right, so now what we want is we got to set up a couple of different things here. So it's going to ask us some dynamic analysis stuff. So one, we want to go ahead and do our first shot. So this is essentially going to take a snapshot of the operating system. And then we're going to take another shot after we run it, but we're also going to be running procmon to watch what else is doing as well. So it could be network activities, file access, file writes, all these types of things we're also going to be catching. But we just got to wait for red shot to finish, and then we'll do the next part. It looks like there's only a couple of dynamic questions. So pretty straightforward. But red shot is pretty interesting. So the kind of the downside of running all this stuff on the host that we're actually executing the malware on is that the malware will have access to basically disrupt all the stuff we're doing, right? So for instance, we do shot one, it drops it to a plain text file. We run ransomware. What's the ransomware going to do? It's going to encrypt shot number one, and then we won't have anything to compare to. So what I'm saying is that any malware, any malicious file that you're executing on the system where you're also trying to do malware analysis could disrupt your malware analysis. In a lot of cases, you may see where people are taking the data off of the system as soon as possible as they're doing the analysis to disrupt tampering. It's just a thing you have to deal with. All right, so we are capturing, I think. I think we're capturing. I think when we click, let's see, let's go ahead and clear it real quick. Clear. Okay, it's capturing now. All right, so let's go ahead and run it. So we're running it. We want it to fully execute. So we'll give it a second to finish fully executing, and then we'll go ahead and take our second shot. So it's probably going to fill up our events pretty quick. This is a pretty small host. Look how fast the events are accumulating down here. It's quite a bit, right? Like we've gotten over 1 million events in a very, very short time frame. And red shot is probably causing quite a bit of that. But it's okay. So the great thing about procmon, which is this tool in the background process monitor, is that we can filter on the binary. So what we'll do is filter on hop helper once we're done with red shot, and then that'll help us narrow the events down a little bit, so we don't have to look at 2, 3, 4, 5 million events. That's quite a bit. I don't know if you have time to look through a few million, but that's quite a bit. More than I want to look at tonight. All right, so let's go ahead. I'm gonna go ahead and pause this just in case it's tearing everything up. We'll let this finish. Yeah. So lots of, well, not lots, a couple of really good tools. There are other ones such as, what's it called? FakeNet that allows, in FakeNet, basically what it'll do, it will respond to any request, web requests with something so that it thinks it's online, but it's not. So most of these are blocked off from the internet so they can't go out and communicate. And so FakeNet allows it to do some funky stuff, but doesn't actually allow it to go out. So it's kind of allowing it to run through its toolkit or whatever it's trying to do without it freaking out and saying, oh, I can't actually connect out. So I'm not going to do anything, which is common. All right, so let's see what happens. Provide the full path of the key that has been modified. So we have quite a few keys here that have been added, quite a few keys here that have been modified. I'm looking. So we're looking for one that screams persistence. And the tough thing is it's hard to see our screen. Let's see if we can modify our view a little bit. See if it'll help us out any. All right, we're looking. Here's hop helper. Values added. D for user, desktop, hop helper. So we're probably looking for something related to hop helper. Maybe this one, current version run. So this is run. So this is, maybe it wants the whole thing. Maybe it's only showing us a piece of it. So let's add it here. All right, so that was it. Okay, so basically this is persistence run. Is used to allow attackers to continue to persist across a reboot. So it will kick this off. So that's one. So let's look at the next one. Filter the output of Procmon for TCP operations. What network protocol is HOD helper using to communicate? So again, we have millions of events, and we want to filter down a little bit. So one. Probably want to narrow down on process name hop helper. So we can do that in here. So we can just say process name is hop helper.exe. Let's see if this works. It's so many, over 3 million. And I'm assuming it's looking for the .exe because it's in line with the rest of them. So we'll filter on the process name, then we'll filter on network activities, and we should be good. There also shouldn't be a ton of events once we remove everything except hop helper. Man, my eye is twitching tonight. So many events, so many. All right, so we're looking for a network protocol. What do we want to guess the network protocol is? We could say it's 4 letters, a network protocol that is 4 letters. Most of the communication protocols are like 3 letters, right? Like SSH, VNC, RDP. I'm trying to think of one that's also 4 letters. So HTTP, so that's 4. FTP is also 3. Could be FTPS or SFTP. Those are 4. Let's see. It's showtime. Should be a little bit faster. So we have narrowed down from 3 million to 6,300 events. All right, we do need to just do network activity. So we got one more to get through. Look, now we've dropped down even more. So about cut it in half again. We're slowly narrowing down our list of events we have to get through. And soon, 127. We're getting there. How many do we think we're going to have left after removing this one? Maybe half. Let's go with half again. 60. How many we got? Wow, 4. What protocol is it? HTTP. That was the protocol. What a world. Lots of, hopefully a lot more coming out as well to help folks out trying to break in the industry. Can you find the web panel that Hot Helper is communicating with? Oh, that's fun. Let's see. Breach blocker .http. Let's see if it tells us in here. There we go. We can try this and see if it'll let us get out to it. It looked, because both of them are the same, I didn't think it was going to take us anywhere. So that's going to do a Google search. We don't want that. So let's do HTTP. Here we go. Hostname breach blocker. This is the host. Why is it not giving us the IP? So this is, I've actually never heard of breach blocker itself, so that's kind of interesting. Can you find the web panel that Hot Helper has been communicating with? So yeah, I guess this is the panel that they're talking about here. I'm not really sure what it is. I've never heard of it. I don't know. What I'm questioning is whether or not it's like a tool or this is part of their C2. So it says Malware's info collector. So actually, I think this is part of the C2. So that's probably why it's not showing anywhere. So it's part of the C2, which is cool. So you'll see that in a lot of panels where, like, if you have a Cobalt Strike thing, you'll see where all the beacons come in for you. So maybe that's what it is.